Hello and welcome to another edition of WoodChat. I'm Sam.
And I'm Victoria. And today we're delving into a discussion about yet another fascinating industry innovation.
When you think of drones or UAVs...
Sam, for those who don't know, what's a UAV?
Okay, so I'm glad you asked. It's an unmanned aerial vehicle.
Right.
So when you think about drones or unmanned aerial vehicles, forest management probably isn't the first application that comes to mind.
True. And there's a growing body of research around the use of UAVs, coupled with other technologies such as sensors, to help deal with certain aspects of forest management.
As a result of collaborations between industry bodies, companies and researchers, those nifty drones are now being used to capture important, detailed and increasingly accurate data. This data can be used to determine the characteristics of trees within plantations, allowing for virtual measurement of stock, which can in turn aid smart decision making. It also has other uses as diverse as measuring disease impacts, detecting fires, and even locating animal habitats.
We spoke to Dr. Christine Stone, Principal Research Scientist in the Forest Management Program at the New South Wales Department of Primary Industries. Dr. Stone has driven a number of collaborative projects that make use of this kind of remote sensing technology, and we were keen to find out more.
We started by asking Christine what the prompter was to undertake this kind of research.
Well, what I started out in was in forest health. And these are large areas that need to be surveyed, which from the ground is almost impossible. And they normally are done manually, if someone in a helicopter or an aeroplane flying over, which is a fairly costly process. And it's also not that accurate either. So I was looking out for technology to see, well, can we do this cheaply? So that was the beginnings of looking at, but it was from the perspective of forest health. But I quite quickly found out that the companies not only had an issue of finding out where their sick trees are, more importantly, they wanted to know what, in terms of assessment of their resource, where their, what status was their stands at in terms of, standing volume, etc., the condition of the stands. And that actually was a high priority for them. So that's how I got involved, and then I quickly realised I can't do this by myself, or even our team can't do this by ourselves. With a team of researchers from multiple agencies, state departments, the CSIRO, universities and researchers, our colleagues in New Zealand, coming together with multiple objectives, multiple skill sets. And one of the things that this collaborative approach has been able to achieve is that because unfortunately the R&D capacity in Australia has declined, we've brought in not only this collaborative approach, but brought in expertise that traditional forest researchers weren't specialised in. These are people that have just relatively new graduates, for example, who have got degrees in software programming, robotics, those sort of newer data scientists, newer disciplines that we are attempting to harness that are used in other sectors commonly now, and harness them, bring them in. And we've progressed a common theme which is related to the acquisition and analysis of what we call dense point cloud data.
I'm just going to break off there for a second for the benefit of our listeners. You're going to hear Christine refer to this concept of dense point cloud data a number of times throughout this episode, and in case, like me, you're unsure about exactly what that means, I wanted to provide a bit of extra detail. So essentially, scanners can be used to measure various points on an object's surface. Those points can then be used to create a 3D representation of that object. The term point cloud refers to the total set of points used to measure the object, and the more points measured, the denser the point cloud, and the more detailed the 3D representation will be. Hopefully that makes sense. And now back to Christine.
The technology to be able to do this has really only sort of taken off in, say, the last 5 years. But because it's progressing so rapidly, we're iteratively improving what we can do and the options that the industry has. So when we first started, we were principally looking at what was called LiDAR sensors. That's an active sensor that were on airplanes, airborne LiDAR. These sensors give out a pulse, an active pulse. What this LiDAR does is create a 3D point cloud representation of the structure that it's hit. And the pulses hit the top, but they can go all the way down to the ground. So you get a 3D construction. So we started off with LiDAR, relatively low density, and working with our colleagues, developed an operational system where now they can acquire this LiDAR, airborne LiDAR, and then derive spatially explicit inventory attributes. That's now fairly operational, fairly routine. But what's happened is that things have advanced, so there are now multiple sensors that can capture much higher density pulses, and parallel to that, there's commercial software now that can extract and process and analyse point data sets derived through a process called photogrammetry, captured by a simple camera. And what we've done is in the recent report was to compare the quality of the photogrammetry against the quality of the LiDAR-derived data sets. Reason being is that LiDAR is relatively expensive, whereas the camera-derived points are much cheaper to acquire.
Right.
The camera is a passive system, so the points are very dense, but they can't penetrate the canopy. So if you haven't already have what we call a digital terrain model, that's very accurate, you can fly over that with your camera and get a very dense surface. And so what we did was to say, is that surface good enough to derive with the same level of accuracy those attributes that we can derive from LiDAR at a cheaper rate?
Yep.
And have proven to be so.
Okay.
So we worked mainly all this work was done at the stand level. We have now focused from the stand level to the individual tree level. And most recently we've been looking at harnessing those very dense point clouds and putting them in, for example, into a virtual reality environment. Can we see on a screen, can we measure trees on the screen, the characteristics that you would do if you're an inventory crew in the field? And that's showing to be very promising. And so there's all these different options. And to help guide the industry and the managers, we've put out quite a few planning guides, technical sources of information, as well as software such as individual tree counting software, which is freely available from the FWPA website. And what we're heading towards now is capturing data sets, multiple data sets simultaneously and fusing them together.
What's the value of three-dimensional data as opposed to the other data that's available?
Right. Well, what we're moving towards in evaluating all these different sensors and types of data that we're capturing is that we're pushing towards something that's analogous to precision agriculture. Unlike agriculture, forestry is three-dimensional. You know, a stand of mature Pinus radiata is 30 to 35 metres tall. So that's where the three-dimensional data sets come into value, because they capture that 3D structure which is fundamental to forestry, whereas often if you look at a wheat field it's not so important.
Right.
It helps decision-making processes such as application of fertilisers, timing of selective harvesting, etc. If you know how your actual stand is behaving with respect to the topography, and this spatially explicit information captures that.
And so how long then have you had the ability to capture that sort of more three-dimensional data? Is that a relatively new?
Yes. The commercial LiDAR sensors that we initially looked at probably came out about 10 years ago. And as I said, they were fairly expensive, but both the quality of these sensors and the cost of the sensors are coming down. And much more recently, the miniaturisation of those sensors is also occurring, which enables you to take a LiDAR sensor and put it onto a UAV. With the UAV, the LiDAR, cheaper LiDAR on a UAV, you can accurately do tree counts, you can get tree heights, and you may get some idea of the stem characteristics, but just in a general manner. But if you have a radiata crop, where you look where the product yield is extremely important, you need to know that before you, a very good estimate of that before you harvest. Well, then if you need more accurate systems, you get what you pay for. There's a whole range of quality of different sensors, and that's what we've been evaluating. So if you get a cheaper LiDAR sensor, put it on a UAV, it's not going to be as accurate as a very expensive survey engineering grade, surveyor grade sensor, which is very expensive if you put that on a helicopter. However, the quality of the helicopter derived survey grade sensor is far superior. So you can use it for other purposes. And we've demonstrated in the latest FWPA project we've just submitted as a final report that that system, very expensive though it may be, can deliver the quality of point clouds that is required to be able to accurately estimate things such as stem taper, diameter, branching, etc. So again, there's a lot of options, a lot of mix and matches, and what we're trying to do is to evaluate the broad range of these potential applications and give guidance to what they may be suitable for. And it's not just the acquiring the data, then you have to get it and analyse it. And then the outcomes of that have to be then integrated into the decision-making process related to planning and operations in an operational manner.
How widely used is this kind of technology in the industry at the moment?
Something that I've noted in the last, say, 2 years has been the huge uptake of the UAVs. And they have a lot of potential, and it's really a matter of understanding, do a SWOT analysis, understanding and evaluating how good these data sets are that are acquired by UAVs, and where they can fit into some of the challenges that the foresters are currently encountering. For example, in some estates, it actually is quite difficult to get into the plantations. There's weeds and other hazards. So if a UAV can fly in, to use it as a sampling tool, so sort of in effect it could replace an inventory crew. There will never be a situation where they'll totally replace the need for human measurement, but generally we envisage that it will be possible to fly a UAV immediately over the top of the canopy or even below the canopy and assess individual trees. That data can be downloaded and put into, say, a virtual reality environment. And so the trees are actually assessed on the screen rather than people going into the field and trying to do that as it has been done conventionally and traditionally.
That's amazing. I love that, especially that it can go under the canopy.
Well, they can. We're now testing sub-canopy UAV systems. But as I said, you can use a UAV as a sampling tool for inventory, but they're using it to use it for a lot of other purposes, fire management, looking for smoke, but also when there has been a fire and they put a thermal sensor on it and they want to see where the hot spots are, which may be under the ground or in logs that you can't see, the firefighters can't see. When they have a newly established plantation, one of the things that's of importance to see is how successful has the planting been. Well, at this stage, men go out there and actually walk up and down and do a sub-sample. Well, that can be quite easily achieved now with a UAV with a tube camera on it. So there's many applications now and the companies themselves are starting to think of their own solutions to some of the challenges that they're trying to overcome. So it's the uptake of UAVs that has really taken off in the last 2 years.
And why do you think that is? Is it because of the advances in the actual technology, or has the price come down? Or
both. The technology is significantly moving. It's becoming more robust. There's accompanying software that is easy to use. But also this technology has been used in many other areas, many other sectors. It's used for recreational uses. So people are becoming very familiar with UAVs. It's just a matter of harnessing what they can deliver into meaningful operational examples, and that's really taken off. And integrating the data that you derive from these sensors into other existing systems and platforms that the companies can then use. So this whole concept of data fusion is an area that we're going to try and look at. And one of the examples would be that there's UAVs that can now carry two sensors simultaneously. So you can have a LiDAR sensor and what we call a spectral, the camera sensor. And you use the two data sets and you put them together, and so it's able to provide a lot more information when you're trying to characterise your actual individual trees.
With the increased use of this sort of technology, what benefits is it having for industry?
The increased precision of the information that they're gathering, they can tighten their decision-making requirements, either temporally or spatially, and that allows them to fine-tune at a finer grain the type of decisions that they have to make, and through tighter control of planting, site-specific planting, site-specific silvicultural applications. It's not dissimilar to what they're doing in precision agriculture and what the farmers are doing now. They only apply fertiliser where it's needed. They can check whether the maturity of their crops. This is no different, but it's doing it remotely. So this whole idea of sensors collating information, being sent back to a base infrastructure, being processed, and then the products from that analysis is then going into their decision-making data flow system, their information flow systems.
And so the knock-on effects of that would be?
Increased efficiencies and better management of their inventory and their budget.
And is there an OH&S advantage as well? So
That's one of the benefits, absolutely one of the benefits. If there's a reduced requirement to actually go in and measure, inspect plantations or compartments. And we've been talking today mostly about plantations, but there's analogy, and it's just starting to develop in native forests, where it's even harder to gain access. And there's also a lot of information required as part of their harvesting specifications, things like detecting and locating habitat trees. That is very time consuming. We're talking about large areas. So if this technology, this remote technology can assist that process, I'm sure it will be taken up by those companies as well.
What feedback have you had from industry to date?
I think we've had positive feedback in that when we do put a new proposal together, the companies in general are still very keen to invest to progress this. So that's a very good indication that we're delivering what they want. And we're able to display some of the benefits and the deliverables through meetings or gatherings such as Forest Tech, which is